morning, Swans and Falcons, and welcome to Tuesday's maths lesson. Today's date is the 2nd of February, and here is your learning intention. Can I find the rule in two-step problems? Okay, so yesterday we were looking at one-step problems. Today we've moved on to doing it in two steps. Before we start though, I'd like you to do a few warm-up questions. So have a look at these, pause the video, have a go at them, and then switch back on when you are ready to go through the answers. Okay, welcome back. Let's have a look then. That number 1 should be familiar from yesterday's lesson. So 50 goes into our function machine. Something happens to it here and then it comes out as 100. So what might the function have been? What might we have done to that number to get to 100? Okay, well, we might have just added 50, mightn't we? We might have added 50. Let's change colour so it stands out a bit. So we might have added 50. What else might we have done? Is 50 plus 50, that's 2 lots of 50, isn't it? So we might have also timesed it by 2. Okay? If we had other numbers that we went into our function machine, we'd be able to work out whether it was plus 50 or times 2 that was the rule. But on this occasion, we don't know just from looking at one equation. So here we have 10% of 300. That takes you back to last week's learning. If we were to draw our bar model and divide it into 10, because we know that percentages out of 100, I probably haven't done 10 there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're interested in one of these, aren't we? If the whole thing is 300, then one of those is going to be 300 divided by 10, which equals 30, because when we're dividing by 10, we're moving all the digits one place to the right. Okay, divide 26 by 100. Okay, so again, we're moving all the digits 2 places to the left. So our answer becomes 0.26, because the 2 has moved from the tens, 1, 2 to the tenths, and the 1s has moved to the hundredths. Okay, and how many metres are there in 5.5 kilometres? Hopefully you've remembered that there are 1,000 metres in a kilometre. So we've got 5,000, and then half a kilometre must be 500. So the answer for that would be 5,500 metres. Okay. So looking back to what we did yesterday, well, we've got one step on our function machine. What have we done to both of these? What is our function here that takes us from 40 to 8? And then 100 to 20. Pause the video, have a little think about it, and then press start when you're ready to move on. Okay, well, if I know my times tables well enough, I know that there are 5 lots of 8 in 40. I also know that there are 5 lots of 20 in 100. Therefore, my function must be divide by 5. Hopefully you got that. Okay, look at this one. Here's one here. We've got our function is minus 10. So we're putting 27 in. I'm minusing 10 from that. So what's my output going to be? That's right, it's going to be 17. Okay, pause the video, have a go at the other two. Now remember with this one what I said about the inverse. If you're going this way, you're doing the opposite. You're doing the inverse. So rather than taking away 10, what would the opposite of take away 10 be? That's right, it will be plus 10. So pause the video, have a go at these, and then restart when you're ready to go through the answers. Okay, welcome back. So doing the inverse then, if we're going this way, we know the output and we want to find the input. If we're adding 10 onto 115, then our input must be 125. I could check my answer by looking at the input, which is 125, take away 10, and that gives me 115, so I know I've got that one right. Okay, next one, bit tricky. Minus 10 minus 10. Okay, that one becomes minus 11. Okay, a bit trickier when they're the minuses, but hopefully you remember from the work we did before Christmas looking at my negative numbers. Okay, moving on. But sometimes we might have more than one rule that we have to apply rather than just one rule. So we've got 2 rules here. We've got our input. Our input for this first one is 2. We times that by 3, which is 6, add on 2, which is 8. Okay, pause the video, have a go at the other 3. Remember this bottom one, you might have to work backwards, okay? So think remembering the inverse and then restart when you're ready to go through the answers. Okay, let's have a look at the others then. So 10 times 3, what's that? Yep, I can hear you shouting 30. So I've got 30, adding on 2 gives me 32. Next one, 20 times 3. Well, 3 times 2 is 6, so 20 times 3 must be 60. Add on 2 is 62. This one here then, I am doing the inverse, okay? So I'm doing the opposite of what I see here. So instead of adding, I'm subtracting. Instead of timesing, I'm doing what? That's right, I'm dividing. So 17, take away 2 is, I'm going to jot down here to help me, 15 divided by 3 gives me 5. I can double check my answer with this one by going 5 times 3 is 15 plus 2 is 17. So I know I've got the right answer. Okay, will I get the same answer, do you think? If I have the same input, but I do it in a different order, am I going to get the same answer? Pause the video, have a go at these two and see whether or not you do get the same output. Because both of them have got to multiply 4, both of them have got to add 2. But does that mean it will give me the same output? Pause it and then restart when you're ready to look at the answer. Okay, so I have my input of 2 for this first one. I multiply that by 4, which is 8. I add on 2, which then gives me 10. Okay, let's see if I get 10 for the second one. 2 plus 2 is 4. Times 4 is 16. So no, I don't, do I? So it does matter which way round I do it. Now, some of you might be thinking, oh, but Miss Carly, when you do Bob maths, you have to do multiplication by before addition. But actually, with function machines, you do it in the order. You're following the arrow and doing it in the order in which it's shown on the machine, okay? So you don't, it doesn't matter what way round you do it, you will get a different answer. Okay, true or false then? Will I get the same answer? If I have the same input for both of these, will I get the same answer? True or false? What do you think? Pause the video and see if you can prove whether it's true or false for me, and then restart when you're ready. Okay, let's have a look. So what can we have as our input? Let's go with number 5. Let's go with 5 as our input. So we have the same input for both. 5 times 2 equals 10. Times 6 equals 60. Okay, let's see what happens here. 5 times 3 equals 15. 15 times 4, well, I know 2 lots of 15 is 30, so double it again gives me 60. So it doesn't matter. So if I had to write this as one step, what have I effectively done to get from 5 to 60? I multiplied it by 2 and then I've multiplied by 6. So in one step, I could have written that as multiplied by 12. And the same here. Timesed it by 12 if I was writing that function as one step. Okay, so have a look at this one. I could write this as one step. So first one, I'm timesing by 8 and dividing by 2. This one, I'm adding by 5 and subtracting 2. So if I had to write that as one step, what am I effectively doing? It might help to put some numbers into the input and working out the output to help you visualise what that one step might be. Especially for this one, because this one's the one I find trickier to work out. Okay, so pause the video, have a go and then restart when you're ready. Okay, let's put some numbers in our function machine to see if that will help us. Let's just put 2 in. So 2 times 8 is 16. Divided by 2 is 8. So what, if I was doing one step, what have I done to get from 2 to 8? Okay, I have timesed it by 4 because 8 divided by 2 is 4, so I'm timesing by 4. Let's put 2 into this one. 2 plus 5 is 7. Minus 2 is 5. So what have I done as one step? What have I done? I've added 5 and taken away 2 away. So overall, I've added on 3. Okay. Now, function machines are actually really useful for when we're solving word problems. So this is actually a SATs question that I took from test base. And this is a theme park sells tickets online. Each ticket costs £24. There is a £3 charge for buying tickets. How much will 4 tickets cost? Okay, I can put this into a function machine. So I know I want to buy 4 tickets. And I know, in fact, have a go at this yourself. Pause the video, have a go, and then come back and see if you get the same answer as me. Okay, let's have a look then, see if you did get the same answer. So each ticket costs £24. So what function do I need to do if I want to work out what 4 lots of 24 is? That's right, I'm going to do times 24 as my first function. Okay, and then it says there is a £3 charge for buying tickets. Now it's a £3 charge in total, not £3 per ticket. So my next thing that I'm going to do is I'm going to add on that £3. And then my output will be my calculation. So 4 lots of £24. Oh, I've picked a tricky example here. So 4 lots of 20 is 80. 4 lots of 4 is 16. So add the 2 together and I make that 96. Okay. Add on the 3 makes it 99. So I know that the cost of 4 tickets will be £99. Okay. And there we have it. Hopefully that makes sense. Have a go at the sheet, and if there are any that you find particularly tricky, then please comment about those on the blog so that your teachers can help you. And I will look forward to seeing you tomorrow for the next algebra lesson. Take care, bye.